Chemistry is what makes up the world around us, from modern medicine to the little atoms that make up everything in the universe. Today, we'll be exploring a teeny part of this magnificent science. I'm Rob Chase, and this is my crash course. Oh hey, didn't see you there. I'm Rob Chase, and today I'm going to be talking to you about chemistry. At its most fundamental level, chemistry is about how atoms interact with each other. Today I'll be giving you an example of this with an acid, a base, and some pressure. And maybe we'll have a little fun in the process. What are acids and bases, you may ask? Here, maybe this will help you.
Hi, the door's locked.
Hello?
Well,
when you think of acids and bases, you think of lemons and sour faces. Well, if you're in AP chemistry, you should understand them more broadly. Hey now, don't freak out, just take it slow. I'll teach you everything that you need to know. Here's lesson number 1, let's pay attention. Look at the formula son and find the element in front. If it starts with a hydrogen, it's an acid, you crack the case. Not there, check the end. If it's OH, that's a base.
Acids donate protons, and bases they receive them. This rule makes for more simple identification. When faced with a problem, just break out and sing it. Acids donate protons, and bases they receive them.
Now what about solutions? For that we need a genius, specifically a chemist named Svante Arrhenius. According to Svante Swede, when you dissolve a compound, one of two ions is released and the chemical can be found. When an acid is dissolved, the ion that will increase always is hydronium because hydrogen is released. With bases it is different. When you add them to water, they will dissociate with hydroxide as the product.
Acids donate protons, and bases they receive them. This rule makes for more simple identification. When faced with a problem, just break out and sing it. Acids donate protons, and bases they receive them.
When I say Bronsted, you say Lowry. Bronsted.
Lowry.
Bronsted.
Lowry.
Bronsted and Lowry.
Came up with this theory,
Acids and bases.
defined more clearly,
Conjugate pairs.
are what they discovered.
Acids and bases.
Can't have one without the other.
Other.
Still confused? Here's a suggestion. Look at this reaction and I'll teach you a lesson. You see, when the acid gives a proton, the thing that's remaining is its conjugate base, if you know what I'm saying. Now guess what? If you just reverse that reaction, a base takes a proton and forms its conjugate acid.
Acids donate protons, and bases receive them. This rule makes for more simple identification. When faced with a problem, break out and sing it. Acids donate protons, and bases receive them. Acids donate protons, and bases they receive them. This rule makes for more simple identification. When faced with a problem, just break out and sing it. Acids donate protons, and bases they receive them.
Wow, wasn't that helpful? Well, I want to show you a real-life example of how these acids and bases interact, using this, and some of this. Here we are, safely outside in a wide open space. Kids, make sure you get parents' permission before performing this experiment. Also, always make sure you're wearing your safety goggles. Now, let's get started. So what I'm going to do is take this baking soda and pour it into the paper towel. Then, I'm going to roll it up, like so. Alright. Then, I'm going to pour this vinegar into our rock. Now, let's head outside and see what we can do. First, let's take a look at the reaction that's taking place. Baking soda, sodium bicarbonate, NaHCO3, and vinegar or acetic acid, CH3COOH, combine in a bottle. First, the sodium breaks off of the NaHCO3 and forms HCO3. While this is happening, the acetic acid is doing what acids do best, donating a hydrogen ion. After this first reaction occurs, another happens. The sodium that broke off of the sodium bicarbonate combines with the acetic acid, forming NaC2H3O2. The hydrogen ion, donated by the acetic acid earlier, combines with the base HCO3, forming H2CO3. Finally, the H2CO3 decomposes and forms water and CO2. Now, let's see what happens when the CO2 builds up. Ready? Here we go. Any moment now, it should explode. The acids and bases are working together, forming CO2, building up pressure in this bottle. Ready? Here we go. Shake it. Stand her up. If you have a defaulty tripod, you can just hold it like this. You might get a little wet though. At least this is not working well. The cap wouldn't hold the, even though I put it real tight, it doesn't hold the pressure. Oh, wow, wasn't that interesting? Thanks for watching Rob Chase's Crash Course. I'm Rob Chase, and until next time, keep crashing.